we have covered so far that whenever we apply a force on a body, there is an acceleration. This is what we did in first law, then we formulated second law, F is equal to ma, that whenever there is a force on a body, there will be an acceleration. Now consider a situation. Let's take a very big object of mass m, and there is a person trying to push it, or you try to push a very heavy object. Now if the object is very heavy, it will not move when the force applied is small. So suppose this person is applying a force of 10 Newton. Then this object may not move. Now, how many forces are acting onto it? There is a force of gravity, and one force is this, applied by the person. The body is not accelerating in this direction, it's not accelerating even in this direction, which means that the net force on it should be 0. So there should be a force of 10 Newton in this direction, and there should be a force of mg in this direction. And both these forces, this one and this one, they come because of the contact. We call them contact force. So whenever two solids are in contact, there will be a force between them. This force is of electromagnetic origin. It is because of the molecules that the force acts between the two bodies. The normal component of this contact force, that we call as reaction or normal reaction, which is always in upward direction, perpendicular to the surface. So we can denote it by N or R, normal component of contact force. So the contact force may be, say, at this particular angle. So one component will be parallel to the surface, another will be perpendicular. So perpendicular component of the contact force, we call it normal reaction. And the contact force which is along the surface is called frictional force. So in this particular case, if the object is not moving, it means there is a frictional force on this object in this direction, which is of 10 Newton. So net force is 0. On this, one force is this 10 Newton. This is 10 Newton. mg by earth, n by surface, net force onto it is 0. Now imagine the situation that I increase this force to 20, and even now the body is not moving. What does it mean? That now that friction force is 20 Newton. Now the friction is 20 Newton, earlier it was 10 Newton, now it is 20 Newton. If I increase this force to 30 Newton and even then the body is not moving, it means the friction is 30. But a situation will come when this object starts moving. So that maximum frictional force is called limiting friction. So it also means that this force of static friction. Static friction means the frictional force acting between the two bodies in contact which are at rest. So these bodies are not moving with respect to each other. So the force of contact along the surface will be called static friction. And this static friction can vary from 0 to a maximum value. So this does not have a fixed value. So that's why it is also called self-adjusting force. Because when we are not applying any force, this force is 0. When we start applying, this force starts increasing, and the maximum value of static friction is that value at which the body starts moving. Now the frictional force will no longer be called the static friction. So let me see how this force varies by changing the surfaces. This is actually proportional to normal reaction and is equal to mu n, or here on horizontal I can write it mg because n is equal to mg, and here we can call it mu s. But this is maximum force or limiting friction. Otherwise, frictional force will be either less or equal to mu s mg. So frictional force is proportional to the normal reaction, less than or equal to mu s mg, and it will depend on mu s is called the coefficient of static friction. It is just a number, coefficient of static friction, and the value of it will depend on roughness and smoothness of the surface and also the material. So roughness or smoothness will decide the value of the frictional force, and also the material of these two surfaces that decides the value of mu s and hence the frictional force. It does not depend on the area in contact. So mu s is mu s depending on the nature of material and roughness or smoothness. We can take some examples. Horizontal, I have told you, suppose we have an inclined plane and there is an object of mass m. Let us find out the force onto it. So one force is mg and another one is the reaction which is perpendicular to the surface. Now we can resolve this. This is theta. So if I want to take, this is theta, this is 90 minus theta, this will be theta. So mg cos theta and mg sin theta. If I tell you that this object is not moving, tell me the frictional force acting on this object. This is not moving. What is the friction? Mg sin theta is the force acting onto it in downward direction. But if it is not moving, it means there is a frictional force which is equal to this. So this is the force of static friction, mg sin theta. This is how will you calculate. If we keep on increasing this value of the inclined plane at a particular value of this angle, this will start sliding. We can find out even that angle. Okay. Let us say at this angle now, at theta, this starts sliding down. What does it mean? That mg sin theta is equal to the limiting friction force now. So which is mu s mg cos theta. What is R? Normal reaction is mg cos theta. So frictional force, limiting friction will be mu s R, which is mu s mg cos theta. Maximum force. So this will be equal. So mu s will be sin theta by cos theta and mu s is tan theta. We also call this angle as angle of repose. That minimum angle of inclined plane at which the body starts sliding, that is called the angle of repose. So in that case, it is just ready to move down, then the maximum force of static friction will be equal to the downward force. From here we can find. This is an experiment also. We can find out the value of frictional coefficient, static frictional coefficient, mu s, by using an inclined plane. You keep on increasing the value of inclined plane, and at whatever angle it is starts sliding down, you note down that angle, tan theta will give you the value of friction coefficient. So static friction is the frictional force acting between two bodies at rest, and its value is mu s mg on horizontal surface, otherwise it is mu s into r or n, normal reaction. This is the maximum value of force, which we call as the limiting frictional force, and its direction. So this is the magnitude. As far as direction is concerned, the direction of the frictional force is such that the net force is 0. So if we are applying a force in this direction on this object, direction of friction will be this. If I apply force in this direction, the direction will be opposite. So that's why we call it self-adjusting force. So in magnitude also, it adjusts its value from 0 to this maximum force, and same way in direction also. In direction, the direction of this force is opposite to the effort, opposite to the direction in which we apply the force or the external force is applied. Okay, now kinetic friction. Kinetic friction is the frictional force acting between two bodies along the surface, and the two bodies are in relative motion. So this is the frictional force acting between two bodies in contact and in relative motion. So if this body is moving in this direction, I'm not taking at rest now. So this is moving in this direction. Let us see what is the direction and what is the magnitude of the force of kinetic friction. This is the kinetic friction now. Frictional force that acts between two bodies in relative motion. So this is acting, this body is moving towards right. Force of kinetic friction is equal to mu k into normal reaction. So it is also just like the force of static friction, the only difference is that there, this is self-adjusting. So this is either less than mu s n or equal to, but kinetic friction force is fixed. It's not adjusting force. It is proportional to the normal reaction, and mu k is called the coefficient of kinetic friction, and its value again depends on roughness or smoothness of the surfaces and the material. And now let us see what is the direction of this force. Direction of static friction is such that the net force on the body is 0. Direction of kinetic frictional force is always in such a way that it opposes the relative motion between the two objects. So what does it mean? This is at rest and this one is in motion. So what is the direction of motion of this with respect to this? It is forward. So what will be the direction of frictional force onto it? It will be in this direction. This one moving in this direction with respect to this. So the frictional force onto it will be opposite to that. We will take few more examples. Let us say we have an inclined plane, an object is kept like this is theta and This is mg, and again we can have mg cos theta, mg sin theta. This is a normal reaction. What will be the direction of frictional force in this case? Kinetic friction. So the body is sliding down. So with respect to this, it is coming down. So the friction force onto this will be in this direction. So the direction of the frictional force, kinetic frictional force, is always opposite. It is such that it tends to destroy the relative motion. This is at rest, this is moving in this direction, so this is the relative motion. And friction will try to destroy the relative motion. It means it will act in this direction. It will try to reduce the speed of this body. That is the nature of the friction force. So this is how we determine the direction of static friction and kinetic friction. There is another type of frictional force which we call as rolling friction. In rolling friction, the body does not slide on the lower surface. What happens in this actually? If I roll this, a body is coming in contact. For example, if this is moving like this point will come in contact with this surface and then it will move up. So every point, no point is actually sliding. It is coming in contact and then moving up, coming in contact and moving up. So as a result, the rolling friction is actually very less. Ideally speaking, it is zero. So in this case, if we have to push an object, here it will be easier to push it than in this case. So that's why in machines, wherever one part has to move against the other, we use ball bearings. Small metallic balls are used, and if I take the same example, a surface onto it, another surface, I need to push it, we will need some force. And if I put small metallic balls and then I keep this object onto it, now it is easier to slide it because rolling friction is much less than this value. Same way, force of kinetic friction is less than the force of static friction. Okay, now we can take one or two problems to write the equations for force if the friction is there. I'll take one or two examples so that it is clear how can we write the force equations. Say this. One force is mg. Let me take this as m1 and this as m2. So it is m1g. Tension always acts towards the point of suspension or towards the pulley. For this, m2g tension, it will be same. If the string is same and the pulley is frictionless, the tension remains same throughout. Okay, then this and 1 will be the normal reaction. Now this can be resolved into two parts. m2g cos theta, m2g sin theta. Frictionless surface. But if there is friction and we suppose that this is moving down, then this will be the direction of friction. Net force acting on both the bodies is responsible for producing acceleration, Newton's first law. So net force is always equal to ma. This is how we write the equation. What will be the equation for this? If it is moving down, m1g minus t is equal to m1a. And for this, it is moving along this, so t minus downward, there are two forces, m2g sin theta plus friction, friction is F, okay, is equal to m2a. And what is F? F is mu k into n. Mu k, what is n? N is being balanced by m2g cos theta. So these three equations, and we can solve and find out the value of tension and acceleration. You can take some more examples. Let us take again the example of a pulley and a block. In this case, M1G down, tension up for this, M2G, normal reaction, tension, and if it is moving, then this is the friction. For this, M1G minus T is equal to M1A. For this, T minus F is equal to M2A. And what is F? It is mu K into N, and N here is simply mg. This is how we can write various equations and find out the value of acceleration or tension. Now these magnitudes and directions of the frictional force, static friction and kinetic friction, they can be written in the form of laws also. We call them laws of friction. So you can include in that the friction, static friction is a self-adjusting force. It is less than or equal to mu SR. Direction such that the net force on the body is 0. The force of kinetic friction, it is equal to mu K into R. Direction such that it opposes the relative motion. It tends to destroy the relative motion. And the frictional force is independent of the area in contact. So these can be summarized in the form of law of friction. Then one, I define the angle of repose, the minimum angle of the inclined plane at which the body moves down.